Hello students, welcome to another live episode of Chakravyuh series. Here we are going to discuss about the chapter ray optics, and if you have joined the stream, please say your comment in the live comment section so that I can see whether you are here or not. Okay, so let's see if you can hear me. Hi Srinivas, hi Shagufta. So let me know if your practical exams are over, I hope, and how was it? Let me know in the comment below. Good evening Srinivas. Yes, so I will start ray optics chapter. It is a very important chapter in terms of overall concept of your PU exam, as well as if you are preparing for KSET exam also. This is a very important chapter, and by practicing more and more MCQs from this chapter, you will get an idea what type of questions you can expect in your PU exam. Right, so basically in Chakravyuh series we are trying to solve more MCQs to make you prepare for your PU board exam, and I have seen that even the questions was easier, you are still making very silly mistakes, so you have to practice. Yes, good. Navyasri, yes, good to hear that. It's Maddie09. Hi Maddie. Hi Raghu. Okay. Shagupta is saying, yes sir, practical exam over, exam was too good. Wow, very good. Next, Srinivas is saying, it was easy sir, I got resistance per unit length. Wow, good exam, good experiment, easy experiment. You just need to draw the graph. I hope you have performed the experiment well. Your viva was good. So with that note, let's start with the questions. First question is, in reflection of light, the angle of reflection is more than incident angle, less than incident angle, equal to the angle of incidence, more or less than incident angle. Now they are talking about reflection, so definitely we know from the law of reflection it is yes 1C. Now Vyashri and Maddie, answer with the question number please, so that whenever I am seeing your answer I can say you are correct. Yes, 1C equal to the angle of incidence, but if they change this to refraction, in case of refraction there is no clear picture whether it will be greater or less. So in that case, if they change this option to refraction, then option D will be the correct answer. Same question, instead of reflection, if they give you refraction, then it can be more, it can be less, based on from which medium to where it is traveling. Right, now let's move on to the question number 2. Focal length of a spherical mirror depends on object distance, image distance, both object and image distances, radius of curvature. So another easy question. Let's see how many of you get this correct. Hi GS Jogur. Yes, 2D. So as I said, Ataur and Maddie, please mention the question number. Srinivas is saying 2C, Navyash is saying 2D, Shagupta is saying 2D. Okay, Ataur Rahman, mention 2C. If you are answering for this question, mention 2C. Now it is interesting to know that even though the mirror equation says that 1 by V plus 1 by U equals to 1 by F, but more importantly we know that R equals to 2F, that is radius of curvature is equals to 2F. This is the equation, mirror equation. So U and V are related to F with this equation, but F is not related to U and V with this equation. F is independent of this equation, it only depends on radius of curvature. Okay, so radius of curvature is the correct answer for this question. So as I said, even if the question is very easy, very obvious, still many students are making mistakes. I am not saying that making mistakes is a crime. If you are making mistake right now, you have to learn from that mistake, and you should not repeat this mistake in your final PU board exam. Okay, that is why I am here. So radius of curvature is the correct answer, not option C, both object and image distance. Even though this is the relation, but object and image distance are related to F with this equation. Okay, not the other way around. Focal length is independent of U and V, it only depends on the radius of curvature. Okay, so radius of curvature is the correct answer. Some of you have already already answered it correctly. Right, Ataur. So Vikas also joined. Vikas, yes, welcome. So 2D is the correct answer. Now let's move on to the third question. When an object is placed at infinity from a spherical mirror, the image is formed at. So object is at infinity from a spherical mirror. What type of spherical mirror is not mentioned, but object distance is given as infinity. So where it will form? It will form at infinity, it will form at principal focus, it will form at center of curvature, it will form at pole. Easy question. So I will not waste too much time. I will take few answers. So Shagupta is saying 3B, Navyashri is saying 3C, Srinivas is saying 3B, Vikas is saying 3D. So all sorts of answers are there. Okay, so no matter what is the type of mirror, it can be virtual image, it can be real image based on what type of mirror you are using, but image will always be formed at principal focus. Okay, it will not be at infinity, it will not be at center of curvature, it will not be at pole. Okay, it will always form at principal focus. The definition of principal focus is that when a parallel ray of light falls on a mirror, wherever it either meets or appears to come from, that is called the principal focus, right? So principal focus is the correct answer. Again, simple question, still many of you are still confused. Center of curvature is when the object is placed exactly as center of curvature. For concave mirror, you will get a image at center of curvature. Okay, for convex mirror, it does not matter, it will always give you virtual image. Okay, but for any mirror, whether it is convex, whether it is concave, the image will be always formed as principal focus. Be careful. Okay, now next question. The focal length of a spherical mirror is equal to the radius of curvature 2 times the radius of curvature, half of the radius of curvature, not depends on the radius of curvature. I gave you the formula, so if you know the answer, please go ahead and let me know the answer. I already given you the formula for this question. Okay, 4C, Srinivas is saying 4B, Yashashwini is saying 4C, Maddie is saying 4C, Shagupta 4C, Navyashri 4C, Vikas 4C. So what is the 4C? Half of the radius of curvature. So I already gave you the formula is that radius of curvature is basically twice of the F. So focal length will be half of the radius of curvature. Okay, so not B. Okay, not 2 times radius of curvature, it is half of the radius of curvature. Radius of curvature is 2 times focal length, so focal length should be half of the radius of curvature. Be careful, again, simple easy question, just use a little time, you can answer such questions. For reflection in spherical mirrors, all distances are measured from, so this is based on the sign convention of mirrors. So distances are measured from pole, principal focus, center of curvature, from object. From where do we measure the distances? All the distances, object distance, image distance. From where should we measure the distances? 5A, Shagupta, Ataur 5A, Srinivas 5A, Shubham, mention question number. As I said, Vikas 5A, Yashashwini 5A, Shubham is also saying 5A. Yes, so obviously we measure the distances from pole for a given mirror, right? Now question number 6. Okay, before going into question number 6, a small promotion here. So as you know that we have already launched Abhyas KSET test series, and if you have not yet enrolled, the link is given in the description of this video. You can go and enroll after this lecture is over. Don't go right now. Okay, let's this lecture be over, then go there and register for Abhyas test series. Currently 4 tests are completely free. You can get it for completely free. Only thing that you have to do, you have to register for it, get the feel. Later on, if you decide, okay, I want to purchase it, you can purchase it. Currently the price is $14.99. That includes your PU2 preparation test series, which is just available for rupees 1. If you are just interested in KSET series, then it is $14.98. Okay, you can spend 1 extra rupees for your PU board preparation as well, right? So this is all, and 31 paid test series will be available from 17th of March once your PU board exams are over. Right now you can enjoy this 4 free test that is available, okay, with solutions, with explanations, everything is there. Okay, and once we launch from 17th of March, it will be a you can answer the questions like just like you are appearing for online test. Okay, so you can track your time, you can compare your marks against your peers, so everything will be there, live scoreboard will be there. So chapter wise one shot videos obviously, and chapter inside 5 years KSET exam, so everything will be provided through our channel. So you have to go down in the link and register yourself today. Now let's move on to the question number 6. In refraction of light, sin I by sin r equals to 1, I by r equals to constant, sin I into sin r is constant, sin I by sin r is constant. So it is about refraction. Easy question, right? Refraction of light, which one is constant? Make a video on numerical problems. GS Jagur, if you have missed it, in our Brahmastra series I made 2 videos, not one, 2 videos on numericals, and I have solved 10 plus 10, 20 very important numericals that is likely to come in your PU board exam. You can go check that out. I will try to find that link and I will share this in our WhatsApp channel. If you have not joined our WhatsApp channel, definitely you can join our WhatsApp channel. Subscribe to this channel. That's why I said subscribe to this channel and click on the notification icon, so that whenever we are doing a new video, you should not miss that out. Okay, 20 very important videos are already done in our Brahmastra series, along with the solution, along with the complete explanation, along with the strategy as well, what should you study for your numerical questions. So that is very important. So question number 6, I can see most of you are answering 6D. Yes, Shagupta, Navyashri, Ataur, Srinivas, Shashwini. If you see the numerical, is it enough for score full marks? Yes, I can guarantee that. If you see those numericals, yes, values will be different. You cannot remember all the numericals and say, sir, the value are different, the problem was slightly different. Yes, some plus or minus will be there, but definitely if you practice those numericals, it is very a good chance. If you solve all the numericals that is given in the videos, you will get 2 numericals for guaranteed. Okay, values will be different, but problems pattern will be same. Okay, that was very well thought of problem. Yes, question 6 option is D answer. So I hope that answers your queries. Okay. Now let's move on to the question number 7 for total internal reflection of light. Now we have moved into total internal reflection. So we started with mirrors, deflection, then mirrors, then refraction, now total internal reflection. Light should travel from rarer medium to denser medium. Light should travel from denser medium to rarer medium. Light should incident along the normal. The angle of incidence should be equal to 90 degrees. So which one of them is correct? Right? Shagupta, Ataur, Yashashwini, Navyashri, all of you are saying 7B. So 7B, light should travel from denser medium to rarer medium. Obviously, I am no one to doubt your answers, right? No, it is correct answer. So correct answer is light should travel from denser medium to rarer medium. Question number 8. An object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image, a real diminished image, a virtual enlarged image, a virtual diminished image. First you answer this question, then I will explain it. Okay, so Shagupta is saying 8C, Navyashri 8C, anyone else? Okay, so you have a concave mirror and we have, this is the focal length. Object is placed within the focal length. Within the focal length means the object distance is less than that of the focal length. So less than that of the focal length means we'll get a virtual image. We'll get a virtual image for mirrors, virtual image formed behind the mirror, right? So we will get a virtual enlarged image, right? Concave mirror forms virtual enlarged image when the distance is less than the focal length. So virtual and enlarged image, similar to that of the convex lens. Convex lens and concave mirrors are cousin brothers. Similarly, convex mirror and concave lens, they are also cousin brothers, right? Next, question number 9. The speed of light in a medium depends on angle of incidence, angle of refraction, refractive index, its mass density. So speed of light in a medium, which factor it depends? Very easy, straightforward question. I hope most of you will get it. Ataur Rahman is saying 8C was correct. Pooja mentioned question number. Say if you are saying 8B was not correct. 8C was correct. Okay, Shagupta is saying 9D. Navyashri is saying 9C. Pooja is saying C. Again, Pooja mentioned the question number. Uday, hi Uday joined late. 9D. Yashashwini 9C. Crunchy boy 9C. Ataur is saying 9C. So, who is saying 9D? Mass density, speed of light does not depend on mass density. Okay, mass density can be higher for certain substances, but still speed of light can be less. So it depends only on refractive index. The example is given in your textbook is about turpentine oil. Turpentine oil is one of the examples which has a mass density higher than that of the water, but the mass density is less than that of the water. So it basically floats on water, but its refractive index is more than that of water. So basically speed of light in turpentine is less compared to that of water, even though the mass density is less than that of the water. So it does not depend on mass density, it depends on the refractive index. Higher the refractive index, less is the speed. So for example, air has a refractive index almost equals to 1, whereas glass has a refractive index equals to 1.5. Crown glass, okay, no, not crown glass, flint glass. Flint glass has a refractive index equals to 1.5. So that means speed of light in glass is much less compared to that of in air. In fact, 1.5 times less than that of in air. Okay, so refractive index of a medium depends on thickness of the medium, angle of incidence, mass density of the medium, optical density of the medium. Okay, yes, 9C was correct answer. Uday and Shagupta, your answers were incorrect in the last option. It will be 9C, not 9D. Right, now let's see which one is the answer for 10. (10A), 10B, 10C, all sorts of answers I received. Shagupta is saying 10C, Ataur Rahman is saying 10B, Navyashri is saying 10A, Srinu is saying 10A. Okay, so refractive index of a medium does not depend on the thickness. Okay, no matter what you have taken, suppose you have taken a glass slab of this much thickness or a glass slab of this much thickness, okay, the refractive index for both the glass slabs will be same. Similarly, if you consider water in a glass, say up to this much, or you consider the water in a same glass up to this much, refractive index will remain the same. Refractive index does not depend on the thickness of the medium. It does not depend on angle of incidence. It does not depend on mass density. We have discussed that in our last question only. It only depends on optical density of the medium. Now I don't know whether you have answered it intentionally incorrect or you just confused. So optical density basically relates to refractive index. Higher that optical density, higher is refractive index. Straightforward, direct proportional relation. Okay, in fact, refractive index itself is called sometimes as optical density, right? So refractive index basically depends on refractive optical density of the medium. Now, next question. When a light ray travels from rarer medium to denser medium, its velocity increases, velocity decreases, wavelength increases, frequency decreases. So light ray is traveling from rarer, say air, to a denser medium, say water, for example. Okay, so light ray is traveling. What happens to this light ray? Speed increases, speed decreases, wavelength increases, frequency decreases. So 11B, Shagupta is saying 11B, Ataur is saying 11B, Srinu is saying 11B, Navyashri is saying 11B. So yes, when the light travels from a rarer to denser medium will always have higher speed. Because of that, the light ray bends towards the normal because its speed decreases, right? So when light ray is traveling from rarer to denser medium, the speed of light decreases, that is velocity decreases. Now you have to remember that wavelength also decreases. Wavelength also decreases. Okay, but frequency remains the same. Okay, so these are the important points. Even though the question is asked but the different options were given, then in that case you have to understand that wavelength decreases as light ray is traveling from rarer to denser and increases when it is traveling opposite way, that is from denser to rarer medium. But frequency of light always remains constant, does not matter where it is going. Frequency of light is a fundamental quantity, it does not change, it changes only when the color of the light is changing. So for a given color of light, frequency is always constant. Okay, now question number 12, Snell's law fails. So very important, Snell's law fails. Snell's law is not always correct. There is a condition when it fails, when light travels from denser to rarer medium. Oblique incidence, when light travel from rarer to denser medium. For normal incidence. So which of the option is correct? Uday Kicha is saying, sir, where can I get complete chapter explanation? Search for the chapter, you will get in this channel. Okay, so Srinivas, we have done chapter explanation for KSET and all the important questions for your PU board preparation, that you can see on our Brahmastra series and KSET series master stroke currently going on. We have done a long elaborative explanation series, 60 out of 60, but right now you don't have the time to see all the 60 out of 60 series, which we did almost 3 to 4 months back. Now right now we are currently running KSET master stroke series, where we are doing one-shot videos, quick revision of the entire chapter, focused on KSET, but if you want, you can study those concepts for your PU board also. Nothing is excluded, but if you want focused PU board preparation, PU2 Brahmastra series is there, where I have explained all the concept question by question. Okay, so that is not based on the exact concept. Whatever important questions are coming, based on that, whatever concepts are there, I have explained there. Okay, all the teachers actually explained there. Now Snell's law fails in case of, most of you have answered it correctly, 12D normal incidence. So when the light ray falling normally, sin 0 is 0, so it does not matter whatever is the refractive index, sin 0 is 0, sin r is also 0. So in that case Snell's law cannot give you the correct value. Now next question, the principle of optical fibers is reflection of light, refraction of light, dispersion of light, total internal reflection. Another easy question. Oblique incidence. Ataur oblique incidence means when the angle is not 0. Any other incident other than normal incidence is called oblique incident. Okay, so this, for example, the angle of incidence in this case is called oblique incidence. Okay, so if the angle is, it is not normal, then it is oblique. It can be from this side, it can be from this side, it does not matter from where it is falling. As long as it is not normal, it is an oblique incident. Okay, and if it is not perpendicular, this is generally not considered for refraction, but if the angle of incidence is between 0 and 90, you can call that as oblique incidence. Okay, I hope that clears your doubt. Okay, now so the question is obviously 13. I see most of you have answered it correctly. 13D, Maya, Manya, Uday, Shagufta, Pratiksha, Pooja, Vikas, Yashashwini. So total internal reflection is the thing that we use in optical fibers. Easy question. Question number 14. The focal length of a lens depends on refractive index of the material, radii of curvature of the two surfaces, diameter of the aperture. Okay, only option 1 is correct, only option 1 and 2 are correct, only option 2 and 3 are correct, option 1, 2, 3 are correct. So on what the focal length depends? Refractive index, radii of the curvature, diameter of the aperture. This is the interesting question. So Uday is saying 14B, Shagufta 14B, Vimal 14B, Manya 14B, Pooja is saying C, Pratiksha is saying 14B, Ataur is also saying 14B. So obviously we know that lens maker formula 1 by F equals to n minus 1, assuming the first medium is air, it is n minus 1, 1 by R1 minus 1 by R2. Right, so if you see in this expression, that is lens maker's formula, it depends on the refractive index of the medium, it depends on the radii of the curvatures of both surfaces. Right, there is no mention of diameter of the aperture. Aperture is not coming into the focal length. Okay, so more the diameter of the aperture, more light it can collect. Other than that, there is no rule for the diameter of the aperture. So basically option 1 and 2 are correct. So option 3 has option 3 has nothing to do with the focal length. So you have to understand on which concept this question was based. This question was based on obviously lens maker's formula. Now question number 15. Two thin lenses of focal length f1 and f2 are in contact. So the power of the combination, very important, not the combined focal length, power of the combination. Okay, let's see how many of you. Chandan, hi Chandan. So how many of you can answer this question correctly? Let's see. Two thin lenses of focal length f1 and f2 are connected, are in contact. So power of the focal length. I am giving you a few seconds to answer this question. Let me drink some water in between. Okay. So Uday is saying, Vimal is saying a lot of questions. Shagupta is saying 15B. Okay. Vimal is saying 15A, Pooja is saying 15B, Uday is saying 15C, Chandan 15B, Ataur saying 15B. Hello Pooja. Charan, talk to me. Ataur also saying 150C, not 150C, 50C, 15C. So let's see what is the focal length. So focal length, combined focal length, suppose 1 by f. So basically it is 1 by f1 plus 1 by f2, right? Two lenses in contact. Now if you add them, what you will get? You will get f1 f2, and this will go up f2 plus f1. Okay, so this is f1 plus f2 by f1 f2. Now what is 1 by f? 1 by f is the combined power. 1 by f is the combined power, so power is equals to f1 plus f2 by f1 f2. This is the long way answer. This is the long answer. There is a shortcut way also. So if you see, these two are basically combined like a resistances in parallel, right? So resistances in parallel, there is a shortcut way to calculate the focal length. That is f equals to f1 f2 by f1 plus f2. Same formula as resistances in parallel, right? So in that case, power is basically 1 by f. So that will be equals to f1 plus f2 divided by f1 f2. Slightly shorter and much crispier answer. If you remember this formula, it will help you to solve numerical question in case you are coming across such questions. So definitely option B is the correct, not option C. Option C would be correct if they ask you focal length. That's why I said be careful while answering this question. Option C would have been correct if they ask you about focal length, but they have asked you about the power. So power is 1 upon focal length, that is f1 f2 by f1 plus f2, sorry, by f1 f2, right? Charan, 15C, no, 50C, not 15C, 15C, not 50C. Okay, we have not reached question number 50, it is only 15, right? Now next question, I don't do very long sessions, I just do focused 30 questions, that's it. So now question number 16. The angle of minimum deviation of a prism depends on, it is not is, it will not be is, it depends on only angle of the prism, only refractive index of the prism, angle of incidence, both angle of the prism and its refractive index. So angle of minimum deviation, what is the formula for angle of minimum deviation? Okay, so the type of type of the prism is not given. General prism, we know what are all the formulas. So you have to understand this. Only refractive index of the prism, angle of the incidence, both angle of the prism and refractive index. So let's see. Chandan saying 16D, Savit is saying 16D, Vimal 16D, Uday 16D, Pooja 16D, GS Jogur 16D, Ataur 16D. Okay. So we know that refractive index of the material of the prism is given by mu equals to sine A plus delta m by 2 divided by sine A by 2. So definitely this is the smallest possible relationship. So from here we can say that mu sine A by 2 is basically equals to A, and if we take sine inverse on both sides, then we get A plus delta m by 2. So from here we can say that delta m is basically 2 sine inverse of this entire thing mu sine A by 2 and minus A. This is the formula for delta m. So we can see that delta m depends on refractive index as well as the angle of the prism. So it depends on both angle of the prism and refractive index. So option D is the correct answer. Right? Next, move on to the next question. A ray of light is incident on glass air interface at an angle greater than the critical angle for the pair of the media. Then the ray undergoes. So light ray incident on a glass air interface at an angle greater than the, so glass to air, it is going from glass to air and the angle of incidence is more than critical angle. So what will happen to this? So angle of incidence is more than that of the critical angle theta c. Partial reflection, partial refraction, total internal reflection grazes the surface at the interface of the two media. Okay, which one is the answer? 17C, Pooja, Kiran 17C, Chandan 17C, Uday 17C, Lakshmi 17C, Ataur 17C, Sky 17C, Shagupta 17C. Yes, so it will be total internal reflection. As long as the angle is more than theta c, it will be total internal reflection. In case the angle is equal to theta c, then option D would have been correct answer. So in case they ask you the same question, but they change the language saying that now the light is fall exactly at the critical angle, then what will happen? It grazes the surface at the interface of the two media. So be careful if the question language is changed. So the magnification of a refracting telescope is, now this is a complete knowledge based question. If you know it, you can answer. If you don't know it, you cannot answer. Let's see how many of you. Shivalinga, whenever you answer with the question number so that I can guess if you are answering the correct question or you are answering a previous question. Okay. KKSGG is saying FE by FO. Bimal is saying C. Let's see. Uday Kicha is saying 18, not 18, Uday, 18, 18B. Chandan is saying 18D. Okay. Shivalanga is saying C. Sky is saying 18A. So in fact, this is a knowledge based question. You have to remember that magnification for a refracting telescope is given by FO, objective lens, divided by eyepiece. Okay, so magnification is basically focal length of the objective lens divided by the focal length of the eyepiece. That is why generally we keep a higher focal length objective lens and a lower focal length eyepiece, so that our magnification is greater than 1 and much greater than 1. So option A is the correct answer. So I can say Shivalinga, he changed his answer. Initially he answered C. Only Sky is answered correctly and Shagupta. Okay. Right. Next question. 19. A lens of large focal length and large aperture is best suited as an objective of an astronomical telescope since. So why we use large focal length and large aperture? Both are large. Focal length is large and aperture is also large for a astronomical telescope. Astronomical telescope means what you use to see distant stars, moon, Jupiter, or even further objects. Why we use larger aperture and focal length? Large aperture contributes to the quality and visibility of the images. Large area of the objective ensures better light gathering power. A large aperture provides better resolution. All of the above. Let's see. So KKS saying 19D, Pooja saying 19D, Navyastri 19D, Uday 19D. Sir, this is this MCQ for cassette or boards? Lakshmi, these are all for boards, okay, but in case sometimes you in cassette exams some board level MCQs also come, not super high amount. 10% of the MCQs, that is 5 to 6 MCQs, are actually board level that you can answer without doing any mathematics, just reading and applying your knowledge. So I have seen, and in fact some older level of cassette questions is now coming to the board level as well, and some higher board level question has increased their standards, and cassette has almost maintaining their standard. So there is some overlap, not high amount, but if you are preparing for cassette, you have to practice these are mandatory for boards. Mandatory for boards. Cassette is it optional, okay. So obviously it is large aperture contributes to the quality and visibility of the images. Large area of the objective ensures better light gathering point. More the size, more light it is gathering. Large aperture provides a better resolution, so higher the size you can get a very clear cut picture. So all of the above is the answer. So 19D is the answer. Okay, most of you have answered this question correctly, right? Now let's move on. Statement number 2 is, and one more thing, all the cassette live sessions are happening in the morning session 11 AM, okay. So if you are interested in only in cassette session, don't forget to join 11 AM session. Tomorrow Ankit sir is taking. Monday I will be taking 11 AM, as well as Monday 6 PM live will also be taken by me. So Monday I have 2 live. Sunday wave optics will be given you as a recorded format, because wave optics I felt was not super important, questions were little easier. So wave optics will be done in a recorded format, but I will be there to answer if you have any questions, okay. So I will be available to answer in chat, not through the video, but I will be answering in the chat as well. So now let's see question number 2. A convex mirror is preferred over a plane mirror in vehicles to observe traffic coming from behind. So as you seen that convex mirrors are preferred, so that is it is called rear view mirrors. Convex mirrors have large field of view, and images of real object formed by convex mirrors are erect. So now statement 1 and 2 both are correct, and statement 2 is not a correct explanation. Statement 1 and 2 are correct, and statement 2 is the correct explanation. So be careful. So first one is not a correct, second one is the correct, okay. So the order generally is given, first one is correct, second one is not a correct, but here they have given both are correct, and correct explanation is in the statement B. Statement 1 is correct but 2 is wrong. Statement D, statement 1 is wrong and statement 2 is correct. So 20, Chandan is saying 20C, Lakshmi is saying 20B, Ataur realized his mistake and deleted the option. Sky is 20B, Uday is saying 20C, Naveshri is saying 20B. So basically what is this? Obviously convex mirrors are preferred as rear view mirrors, as you have seen in bikes, in cars, in cycles, wherever you see there is a rear view mirror, they are all convex mirrors. Convex mirrors are, in fact if you drive in a corner, if you see a large kind of mirrors located at the corner, they are also convex mirrors. If you visit a shopping mall, there is a mirror located big enough so that the manager sitting at some corner, he can check on you whether you are stealing something in your pocket or not, okay. So those all mirrors are convex mirrors, right? And convex mirror can have a large area of collection of light, and it forms a, obviously it forms a erect image, erect virtual smaller image. So that is why if you see a newly purchased car or a bike where it is written that the sizes are not actual to the distance, size does not represent the distance. So even if the image appears in the mirror to be smaller, the objects appear to be much closer than they appear. So we have the perception of seeing in the plane mirror where the smaller image means the object is very far, right? But in convex mirror, since it is forming erect and smaller image, that magnification itself is less than 1, so that is why it is mentioned that objects might be closer than they appear. So if you have to be careful, if the object size is smaller, then that means the object may be slightly closer than you may imagine, Okay, so basically both statements are true, and obviously this is the correct explanation. So Uday, your answer was wrong. It is not C, it is only B. Okay, both are correct, and correct explanation of the statement 2 is the correct explanation of statement 1. Now let's see the again same pattern. We will be solving a lot of statement based question. I think 5-6 statement based questions are there. As statement based questions are very popular nowadays, it is coming in KSET, it is coming in NEET, it is coming in board exam as well, in fact in JEE exams as well. Statement 1, the image formed by a total internal reflection, not forms. Image formed by total internal reflections are much brighter than those formed by mirrors or lenses. In total internal reflection, the light is completely reflected and there is no loss of intensity of the light. Easy question. So I guess by the time I read the question, you should be able to answer. Navyashri, thank you. Navyashri, 30 questions are there, 9 more questions are there. Okay, we have few statement based questions back to back, then we will have some normal questions, then we will close this session. Okay, so so obviously statement 1 is correct. We see the brighter image because all the lights get reflected. That's why the name total internal reflection. If you remember, you have studied in your lower classes, total internal reflection is called so because no light is refracted, entire light gets reflected. That is why we see a brighter image. So statement 2 is the correct answer. Sorry, option B is the correct answer. Now again another statement based question, same pattern. So B is the point where all of them are correct. A is where correct, both correct but not correct explanation. And if you see other options are given, at least one of the statement is correct. Both of them are not incorrect. That option is not given here. Statement 1, the focal length of a equiconvex lens of refractive index 1.5 placed in air is equal to the radius of curvature of either face. Okay, for equiconvex lens, the radius of curvature of both the faces is same. So let's see. We know that focal length is basically 1 by f equals to n minus 1 into 1 by r minus 1 by r1 minus 1 by r2, right? Now equiconvex lens means r2 is basically minus r1, and say that value is say r, right? So what is refractive index? Refractive index is 1.5 minus 1, so it will be 1 by r minus 1 by minus r, right? So let's see, 0.5 into 2 by r, so it will be 1 by r. So f equals to radius of curvature. Okay, so first statement, focal length of equiconvex lens of refractive index 1.5 placed in air is equal to the radius of curvature of the either face. So definitely it is a correct statement. And statement 2 saying that equiconvex lens radius of curvature of the both faces are same. So that is also correct, and that is why when we are replacing the value we are getting this answer. So both statements are correct, and it is basically number 2 is the correct explanation. Let's see how many of you have answered. 21B, but 22, Uday is saying. Navyashri, I explained already. Uday saying 22B, KK is saying 22A. No, not 22A, KK is. Ataru 22B, Yashwant 22A. So be careful. Both are correct, and correct explanation is option B, not option A. So both are correct, and correct explanation, that is for option B. So if you because these questions are taken from your model question bank, okay, most of these questions are taken, not all of the questions, most of the questions are taken from model question bank. If the teachers directly quotes from the model question bank, so you might get this kind of option. So be careful, be mindful when you are answering in the exam. Even though you know the answer, you thought okay, in KSET, in NEET, in JEE option A generally gives both of them are correct and correct explanation, so you just blindly answered option A. Don't do that. Read the options, then make sure you are answering the correct choice. Okay. So in this case, as you can see, focal length is equals to R, and focal length is basically equals to R because of this, that both of the radius of curvatures are same. So both of them are correct, and statement 2 is the correct explanation for option A. Statement 1. Now another statement based question. If a glass prism is immersed in water, its angle of minimum deviation is increases. Angle of minimum deviation of a prism is increased with the increase of the refractive index of the prism. Okay, so what is the question? If you immerse the glass in the water, its angle of minimum deviation increases. So what is the formula? Mu equals to sine A plus delta by 2 divided by sine A by 2. Okay, now you have to remember this mu is basically mu of the glass divided by mu of water. Okay, mu of the glass divided by mu of water. Okay, now in this case, if you first case, when the first it was in air, okay, when it was in air, then it was simply air, so mu was equals to mu g. So for glass we know it is 1.5, but when it is immersed in water, in that case it basically 1.5 divided by 1.33. It is now less than that value, approximately 1.2. Okay, the answer will be the value will be 1.2. So basically what is happening is that the value of this angle is basically decreasing. So sine A by 2, because sine A by 2 is constant, sine A by 2 is constant, right? It is same for the both cases. So sine A plus delta by 2 is decreasing. So sine A plus delta by 2 is decreasing means it is going closer to 0. Right? So we know that sine 0 is 0. So if sine theta's value is decreasing, that means theta is decreasing. So theta is decreasing means now A is constant. So only way it can decrease by decreasing delta. So delta is basically decreasing. So as you are immersing it into the water, okay, its minimum deviation, angle of minimum deviation decreases, not increases. Okay, so basically this is a wrong statement. So as you are immersing it into water, its minimum deviation will decrease and it will not increase. There was a numerical I solved one of the lectures, I don't remember where this question was very common. You can check that out. Angle of minimum deviation of a prism is increases with increase in the refractive index of the prism. Yes, so if you increase mu, definitely the delta will increase. Now in this case, as you can see, mu is getting decreased. So mu is getting decreased means delta is decreasing. If you increase mu, delta will increase. So definitely statement 1 is incorrect, but statement 2 is correct. So statement 1 is wrong, statement 2 is correct. Slightly tricky question. This is a little longer question. In my opinion, slightly higher level question than normal questions. So you have to know for sure to answer this question. Slightly difficult question in my opinion. Now question number 24, another statement and based question, as I said, past as well. In simple microscope, the object is placed at a distance slightly less than that of the focal length. Now I think most of you have some people answered 23rd D, but most of you have answered wrong. Now in a simple microscope, the object is placed at a distance slightly less than that of the focal length of the objective lens. Okay, when the object is placed within the focal point of a convex lens, enlarged erect image is formed. Okay, now let's see which is correct. In a simple microscope, the object placed at a distance slightly less than that of the focal length of the objective lens. When the object is placed within the focal point of the convex lens, enlarged erect image is formed. Okay, so 24B case Chandan 24B. Yes, so both statements are correct, and because we need a erect and enlarged image, so that is why it is placed slightly less than that of the focal length, so that you can get an enlarged and erect image. Erect image is very, very important to get. So both statements are correct, and 2 is the correct reason, correct explanation. Let's see the question number 25. In compound microscope, the focal length of objective lens is large, whereas focal length of the eyepiece is small. The magnification of compound microscope varies inversely to the focal length of both the objective lens and eye lens. Now let's see. I have solved this question. The reasoning behind this question is answered in one of the previous MCQs. So if you have seen that MCQ, you can answer this question. Okay. 25 Uday 24B was correct. Now Navyasri is saying 25B. Now Navyasri, remember that statement, both the statements are correct and statement 2 is correct explanation, then only you should answer B. Okay. So magnification of compound microscope. What is the magnification of compound microscope? I gave you the formula for that. What is the magnification for compound microscope? It is focal length of objective by focal length of eyepiece. So is it inversely to both the focal lengths? It is only inversely to the eyepiece focal length, but it is directly proportional to the objective focal length. So that is why focal length of the objective lens is kept large and focal length of the eyepiece is small. Right? Now just imagine that you don't know the answer. You don't know the answer, then how can you answer this question? So basically you can see that there is a conflict. So both of them cannot be correct. Why? Because if it is inversely proportional means smaller is better, right? So if both of them are inversely proportional, then both of the values should be kept smaller, right? But here they have said one is larger, one is smaller. So they cannot be, either they cannot be inversely proportional, or this is false, this is correct, right? So from there we can see that statement 1 is correct, statement 2 is wrong. So option C is correct. Okay. KKS, no, not 25A. Lakshmi answered correctly, 25C. Yes, KKS correct, 25C is the correct answer. Right? So statement 1 is correct, statement 2 is incorrect. Next question, 26. In refracting telescope, the focal length of objective lens is large, whereas the focal length of the eyepiece is small. The magnification of the refracting telescope directly proportional to the focal length of the objective lens and varies inversely with the focal length of the eye lens. Now same question, they have given the options correctly. Now let's see the answer. So focal length of the objective is large, focal length of the eyepiece is small. Same question. Navyasri, as I mentioned, A is okay. In this case they have changed the option. So in this case they have given in statement 1 is correct explanation for statement 2 is correct explanation for statement A. So now they have changed the order. Now question A is both correct, question B is not correct, both correct but not correct explanations. So 1 is correct, here 2 is correct. Right? So both statements are correct. As we have seen in our previous question, both statements are correct, and obviously this is the correct explanation for the statement 1. So option A is the correct answer. Let's move on to the next question. Identify the statement which is true for a compound microscope from the following. Now we have completed all the statement based questions. Now we will see few normal questions. The objective of a convex lens is of greater aperture. Eyepiece of a convex lens of greater aperture. The image formed by its objective is real and inverted. Its eyepiece produces the final image which is virtual and diminished. Let's see. Compound microscope, okay? 27A, 27B. So in this case 27A is okay, but objective lens, convex lens is not very high in aperture. Okay, even though aperture of the convex lens is greater than of the eyepiece, but you cannot say that aperture of the convex lens is very high. Okay, but you can say that the aperture of the eye lens is small, so that your eye can be fitted and you get a clear image. So 27B is the correct answer in my opinion. Okay, so 27B should be the correct answer. Now in internet 27C is shown as the correct answer, which is in my opinion again is wrong. Okay, so 27B should be the correct answer for this question. Now 28, modern telescopes called reflecting telescopes use a concave mirror rather than a lens for the objective, because no chromatic aberration in a mirror, giving mechanical support to a mirror is easier. Okay, 1 is true, 2 is false, 1 is false, 2 is true, both 1 and 2 are true, both 1 and 2 are false. Let's see how many of you can answer this question. 27 I answered na Chandan? I answered it. Option B is correct, 27. Option B is correct, yes. 28A. 1 is true, 2 is false. So modern telescope use reflecting telescopes. So if you see refracting telescopes are not super useful, and we do not use too many refracting telescopes. One of the most common well-known refracting telescope was Hubble Space Telescope, which is located in space, not on Earth. Okay, all the other telescopes that we use here on Earth, okay, we generally use reflecting telescopes. Okay, most of the common telescopes are reflecting telescopes, because you can use a very large mirror. There are some drawbacks also, but main reason is that you can collect a large light coming from a very distant star. So even the star is very tiny, you can still see it clearly if you focus it properly. Secondly, obviously when you are considering a lens, for a lens you can only support it on along the rim. If you have seen the lens, okay, the spy lens or the convex lens available in your home, if you have seen that, they are basically only along the rim. But mirrors, on the other hand, you can support it from the entire back. You can support it from the entire back. So no matter how big you are making it, it can still hold by supporting it from the back end, right? So both the statements are true. 1 and 2 both are true. This question came in last year's PU board final exam. Okay, so question was taken from there. Now question number 29. Snell's law is invalid for the angle of incidence. We have seen this question, but here it is given in terms of angle of incidence. So let's see how many of you can answer. Yes, both Chandan, both 1 and 2 are correct, not A and B are correct. Okay, both 1 and 2 are correct. So KK is saying 29th A, Navyashri is saying 29th A. 29A, not 29C. Sure? Sure? Yes, normal incidence means angle of incidence is 0, not 90 degrees. Okay, so even though normal generally represent 90 degree, but for normal incidence, angle of incidence is 0. Okay, so yes, correct answer is option A. Now last question. A light of frequency nu and wavelength lambda enters to a glass medium from air. Nu will remain constant and lambda changes. Nu changes and lambda will remain constant. Both nu and lambda will change. Both nu and lambda will remain constant. Okay, so nu is the frequency and lambda is the wavelength, right? So Ullas Yadav came late. Last question. So you answered option A. KK is saying A, Navyashri is saying B, Chandan is saying A. Okay. So yes, option A is correct. Nu will remain constant and lambda changes. So I have mentioned this in our previous question as well, that frequency of light is constant unless you change the color. Okay, if the color of the light is same, the frequency remains same. For a monochromatic light, nu remains same. Okay, for colorful lights, they incident at a different angles. That's why we see dispersion of white light, that is the rainbow. Other than that, if it is a monochromatic single new light, then the frequency will remain constant, wavelength will adjust accordingly. Okay, and if you remember, there is another equation V, that is speed of light is basically nu into lambda. Okay, so lambda will change, V will change, but nu will remain constant. Okay, so you have to careful about it. Now if you are preparing for your KSET 2025 exam, and if you are worrying about your preparation, how, from where we can practice, we have practiced all the PYQs, we have practiced all the concepts, but we do not have enough questions to practice from anymore. Then worry not, we have Abhyas KSET series where you will get 35 total tests, and out of that 4 is absolutely free. To get the 4 free test paper, you have to go to the link given in the description of this video and register yourself so that you get those 4 free test papers. They are currently available. Once you register, the link will be shared with you. You will get an app link. You can download that app, and you can use the mobile number that you have used to register, and you can get the OTP and log into the app and get the 4 question papers absolutely free. Later on, you can decide whether you can purchase this product or not, and if you purchase it right now, you will get the product 1498 and 1499 for your 1 rupee PU2 test series. So you will get the PU2 test series, which actually priced at 499 at the beginning at the launch, but currently it is available for only 1 rupee if you purchase it as a bundle for your PU2 exam bundle for Abhyas KSET test series, right? And once the KSET test series is live, you will get 31 paid tests. Okay, and it will be live from 17th of March after your PU2 board exams are over. In this series, you will get detailed video solutions and analysis. You will get chapter wise one-shot revision videos. You will get chapter wise insight for last 5 years KSET question papers as well. So all the guidance you need will be provided by us. So don't wait now. You should register, because you will also getting the PU2 test series for ₹1 only, which you can say is basically free, right? So all the best for your PU2 and KSET preparation. And if you have any questions, any comments, don't forget to mention that in the comment below. And obviously I will be live on Monday morning as well as in the evening, and Sunday wave optics will be there as a recorded lecture, but I will be there to answer your questions in the chat section. So you feel free to ask anything in the chat. I will be trying to answering as much as possible. Okay, so with this I will like to close this session. Any questions? Is these questions are enough for boards? Obviously these questions are enough for boards for your optics, ray optics chapter. Okay, one of the chapters generally we expect 2 questions. Ray optics is one of the chapter from where you might expect 2 MCQs. Okay, not only the MCQs, similar kind of fill in the blanks type of questions also come. So if you practice these MCQs, your MCQs as well as fill in the blanks, both requirements are done. Okay, this is only from one chapter. We have 14 chapters. We have almost completed. 4 or 5 chapters are left: wave optics, atoms, nuclei, and semiconductor. These chapters are pending. Okay, we will complete all the chapters, all subject by 26th February. So at least 2 days before your Kannada exam is there, we will be completing all the chapters. So don't worry, all subjects, all teachers will have taken responsibility. They will complete it by 26th of February. So if you follow all the lectures, definitely your requirement for board is done. Okay, and I can say by guarantee that this will help you to score well in your PU exam as well. Okay, with this I will like to close this session. See you on Sunday on recorded lecture, and on Monday again with live session. Bye.